Hi, today we'll talk about scientific topic about motion. Motion actually simply is a movement from place to other. So our motion today is periodic motion, but this is not, as you see, not the main topic. The main topic, something we'll see now. Periodic motion actually has two examples or two types, but actually examples. Two examples. The first one is oscillatory. Sorry, you will notice that the writing here is better. Please slowly, here some fastly. So sorry. Okay, we'll talk about oscillatory, and this is our main topic. Oscillatory motion. Okay, and the second type of periodic motion is wave motion. What is oscillatory and what is wave motion? Simply, oscillatory is like that. It's like that. This is oscillatory. We will take a chain, simple chain, okay, or pendulum. Actually, the scientific example is pendulum, but we will use here chain, okay. What is this? This is motion. This is oscillatory motion. We will see the details of it now, okay. And what is the other example of wave motion? Okay, let's consider this a stone, okay. We will throw it in the sea or river. It will make some types of waves like that. This is wave motion. We will take stone, the stone drop in water, and the waves are confirmed around the stone in this shape, okay. Now we need to talk about wave motion. And sorry, we'll start with oscillatory motion. Wave motion is lesson 2. We will not go in it now. We will talk about oscillatory motion. Okay? Oscillatory motion. So we talked about wave motion last thing, but we will not go deep in wave motion now because our lesson today, lesson 1, is about oscillatory motion. Okay. So, simple example of oscillatory motion, as we said, is pendulum. Again, it's motion like that. We see. So, we have a rest position in the center, and let's draw it to be clearer. Okay. Actually, this is the simple pendulum. Let's draw the center at first. When we have something hanging the pendulum, and the pendulum is going down from this. Okay, this is we name this position as rest position. Rest position. Okay. As we said in the reel, the motion is like that. So, right and left, go right and left. Here, the right, we will use the green color for the right. It goes right like that. And left, blue color, like that. This is actually the simple oscillatory motion. This is simple oscillatory motion, okay? Rest position and pendulum go right and left, as we see. Okay. Now we suppose we define the oscillatory motion. The definition of oscillatory motion. It's so now we need to define the oscillatory motion as a definition. We started, of course, with drawing and talking. This is better because now we can define even, we don't know the actual words of definition, but we can imagine what is oscillatory motion. What from the name, it's a motion. Yes. Okay, let's write it. It's motion. Okay. We can, I think, okay, write it here. Oscillatory motion. Its type here. It's type of periodic motion, of course. Periodic motion. And what happened in the oscillatory motion? It's around the rest position, as we see here. Around rest position. Okay, and we will add one thing that it will be in equal periods of time during. Okay, let's erase this now. We know oscillatory. Okay, oscillatory during equal. Let's draw it. Equal periods of time. So this is the first topic now, or the second point. We talked about periodic motion, and we talked about oscillatory motion. This is oscillatory. Okay. We'll go now to the third point, which is amplitude. Amplitude, actually, it is related to our drawing here. Okay, but we will start another drawing, and we will link the two drawing together now. Okay, let's draw a simple circle, and we will see how this related to the simple pendulum motion or oscillatory motion. Actually, it's simple. Amplitude is a part of oscillatory motion, as we will see. Actually, when we talked about pendulum motion, the motion is like that. When we draw with arrow, is like, right? Then return to the rest position, and continue the way to the left point, and from the left point return the rest position. Actually, this is the oscillatory motion, and amplitude, which is part of this. Which part? It's the part of one trip of these, if we call them trips. Actually, one movement from this. It's let's for example, from rest position to the right point. This is amplitude. So can we define it now? But before we define, let's draw it first. The amplitude will be as not circle as we draw it now. Actually, it is quarter of the circle. How this? Simply we draw it as we said. Let's use green, no problem. We will take this strip, for example, this movement, for example. Okay, we will draw it in another way here. X and Y axis, okay. When we move from the rest position to the right position, we draw quarter of the circle, okay. This is amplitude, and now this is first point here. It's exactly as the right point. This is the same points. We are drawing it as a diagram, okay. We will know a lot about these diagrams, and we will learn together how to draw these diagrams, and we will know the X and Y, what is the name for X and Y. But we want to talk about the subject simply, and to start knowing what is the oscillatory, what is the amplitude, some just expressions, So you will may find the book is different in order, but here we're trying to be in order of understanding, not be a lot of information suddenly. So we'll draw first, then talk about definition, and we'll talk about rules later and details. Okay, so this is the first point, right point. Okay, now we'll return from the right to the rest position. Okay, this is the rest position. So I think you can now suggest or not suggest. Sorry, what I say. You can expect, okay, or guess that this is the x-axis represents the rest position. So, but actually not the rest position itself. But let's say this now. The x is the rest position. So when the pendulum moved to the right point now, then return it to the rest position. So the point is here over x-axis. This is x and y for now. Okay. After that, from the rest position to the left point. So we will go now. This is the point, left point. Okay, and return to the rest position. Okay, I think now we got the amplitude and we can define it quickly. That's its maximum. So this is why, before the definition, this is why I draw a circle at the first, because they're trying to make you imagine more the movement. But actually, this is not our. We will not care about this circle. This is not our draw. Our draw is here. Okay, so I try to. You imagine this is half a circle, continuous circle. But actually, this is the right circle. Wave style. Okay, so amplitude is maximum, displacement, simple definition, displacement away from what? Away from rest position. Okay, from rest position. Okay, last point, we will talk about it completely, because this will talk about it in the next lesson. Okay, this is 4 amplitudes. As you see now, we can suggest that these are 4 amplitudes, right? Right, rest, left, rest. Okay, this is 4 amplitudes. Okay, the 4 amplitudes together confirm something that is called, we will explain next time, complete oscillation. Complete oscillation. And the rule of complete oscillation, simply as we from the diagram, for complete oscillation equal simply 4 amplitudes. And thank you for this quick demo, and thank you for joining and watching. Actually, this is a quick demo, and we will continue in the other lesson. Thank you.